already live. So thanks all for joining us. For me, it's a real pleasure to introduce Gabriela López-Tolsa for this series of presentation at this year EABA Summer School. Okay, I'm going to introduce Gabriela. Gabriela is an assistant professor at the Universidad Complutense de Madrid. She has built an academic career in behavioral science with work on decision-making, behavioral economics, and the acquisition of maintenance of behavior. She has conducted research stays in different countries, supervised master and PhD students, and contributed actively in the field through the scientific societies, journals, and invited lectures around different congresses. Beyond her academic achievements, Gabriela is someone I deeply admire, both as a professional and a person. She's generous, rigorous, and genuinely committed to the field. So for me, is one of those people whose presence makes a real difference in our community, and build a better scientific community. Okay, so Gabriela, the floor is yours. I'm going to be here in order to moderate the questions. So good luck for the presentation.
Okay, thank you very much, Jesus, for that extremely kind words. You know, everything, I feel the same. So thank you very much for the words, and thank you to EABA for the invitation to be here in the summer school. I actually attended a summer school in 2014, 15, something like that, in Cadiz, which was really enlightening and really good. So I am very happy to be here, like on the other side, contributing to this event, which I think is very necessary in the European context. So let's get started. I'm going to be talking about behavioral economics and giving a very brief introduction because this is a very, very wide topic. So I'm just going to be giving a very brief introduction on how behavioral economics can take us from the animal lab to shaping public policies in general. So let's get right to it. So in order to start the presentation, I wanted to ask, why do we analyze behavior? I know that most people here are either behavior analysts or interested in behavior analysis. So this should be a really easy question to answer. And in general, especially if you are in the applied part of behavior analysis, you would say that the main goal of your work is to improve socially significant behavior. So in general, we want to make life better and easier for people, and especially like in a social context. In that sense, research within the experimental analysis of behavior, which is where I am, where I work, should provide the scientific foundations to develop tools that aid to such a task. And I think what I've found in recent years that behavioral economics provide a very strong framework in which the results drawn from the experimental analysis of behavior can be easily translated into applied settings. I find this to be very important because one of the main questions I get, especially from students, when I'm talking about my research is like, okay, so what do we do with this information? How do we apply it? How do we take it out of the lab and use it somehow? And I think behavioral economics can give us a little hand with that, and it can help us do it in a more easy way. So in that sense, I want to talk about what behavioral economics is. I'm going to be using the term behavioral economics on its own, but I'm actually going to be referring to operant behavioral economics, which is a little different to cognitive behavioral economics, which you can imagine it has a lot more of cognition type of things in it. But just know that whenever I'm talking about behavioral economics, I mean the operant side of it. So in order to understand what this is, we have to think of the definition of psychology, which is the science that studies the behavior of organisms. And we also have to think about the definition of economy, which is the science that studies the organization and distribution of resources. And within economy, we have something called microeconomics. You might know that economy is divided into macro and microeconomics. And microeconomics refers to the study of individual decisions and their effect on supply and demand. So if we were to put these two sciences together, we would get what we now call behavioral economics, which is a subfield that combines the principles of microeconomics and behavior analysis to explain behavior, particularly related to choice and consumption of different goods, as they are called in economy, or we could also call them reinforcers, stimuli, etc., etc. Okay, so why should we be interested in behavioral economics? I often find this question funny because the only class that I almost failed in my life was actually economics in high school. So I find it very funny that now I'm working with something that's related to that. But I just think I had to know it a little better just to make sure it was important to know. So whenever I'm thinking about why we should do this kind of research or use this kind of tools, I like to think about how many lives a behavior analyst can impact in a, let's say, 35 years career. So if someone would be working as a behavior analyst, like a normal therapy kind of situation, maybe during this lifetime career, they would be impacting the life of 1,500 to 3,000 clients, something like that. If they were working with within maybe the topics of autism, maybe they would be working or helping out about 170 to 250 families throughout their life. If someone is a professor at a university, they might be impacting the lives of 3,000 to 10,000 students. But I like to think that if someone does research, and especially research that can help to inform public policy, they can actually impact the life of millions of people, if not dozens of millions of people, because as we're going to see, a public policy can change how the world works. So I think I always find it very inspiring to think that something we do in the lab might sometimes help millions of people to improve their life. So how can research impact so many lives? Let's think about the main causes of death in the European Union. We can see that the first two are circulatory diseases and cancer, which are for most part actually potentially avoidable through behavioral change and strategies. This means that if we were to analyze this type of behaviors that can make these diseases less likely to occur, we could actually improve the health and quality of life of a lot of people. So in that sense, behavioral economics can improve people's life through the design of effective public policies. Of course, this is also true for not behavioral economics, but behavioral analysis in general. But as I said, I think behavioral economics is especially useful when it comes to translating results from the lab to more applied settings. So I've been talking a little bit about public policies, but perhaps some of you are not very familiar with what they are. So in general, we would say that they are responses in the shape of strategies that the government provide to banish a social problem. So the government or the people will identify a problem that needs a solution, and the government would provide a strategy or a set of strategies to try to banish or solve this problem. And of course, in order to do so, we would need a combination of these government policies plus the public action. If a policy exists but is not being followed, well, it's obviously not going to work. So of course, the policy also has to be designed in a way in which the public are actually going to implement it or to follow it. This would need interventions from the government, the private sector, and of course the citizenship. So whenever we are talking about public policies, we need to be talking about teamwork in the highest and broadest of the levels we need. Okay, so let's talk about the public policy cycle. We are going to see that this cycle is, of course, repetitive. So let's start with this stage, which would be the definition of the problem. If we don't know what the problem is, we are not going to be able to solve it. So once we define it operationally and know or hypothesize about the variables that are sustaining that problem, we need to design a policy that might change it somehow. And then, of course, we have to implement it and later do a follow-up and evaluation. So in this cycle, the government in all of its levels have to make sure that these policies are implemented through different institutions, secretaries, ministries, etc. And the part of the follow-up and evaluation of also falls within the government institutions job. So for example, for Europe, it's the European Commission that has to oversee if the public policies implemented in Europe are working or they should be renewed or redesigned somehow. And where do we come in? Precisely between the definition of the problem and the design of the policy. It is often the case that the problem is identified, but not the variables that are making it a problem. So that would be our work, our job, to actually find those variables and be able to control them and modify them in order to have an impact or our desired result in solving this problem. And of course, to design the best way in which we can actually implement these changes in order to have the desired change. Okay, so how do we go from psychology or behavior analysis to public policies? There's always a base on non-human animals behavior laboratories. The research that's going on with animals, which is what I do, is still very relevant and can still give us a lot of information about variables that we cannot isolate in people or we cannot control as easily. So there's still a lot of things that need to be done inside animal behavior laboratories. Of course, there are human behavior laboratories, which are often a second step after animal research. And then there's, of course, clinical or field research in which the behavior is observed and we try to manipulate it or measure it outside of the control environment that we can get in a lab. After that, we would do an econometric analysis of the behavior in the real environment. So we would see how these economic variables will be impacting the occurrence of the behavior. Then we would do an experimental or simulated, I mean hypothetical testing of intervention projects. And then there will be a formulation of the public policy and an implementation and evaluation of such policy. Of course, there should be some feedback from those who make the public policies in every stage of this process in order to be able to continue updating and improving these potential public policies. So within behavior, we have two types of tasks that are mostly used in this sense. The first one is the operand. The one is the discounting paradigm, which you might have heard of. So let's start with operand demand framework. With this framework, we want to answer the question of how do we value goods. And for this, I want to introduce you to the water diamond paradox, which is actually a paradox that's that has been used in economy for a really long time, but I think very good illustrates how this actually works. So let's say that you are asked whether a diamond or a bottle of water is more valuable, and maybe most of you would say that, of course, a diamond is more valuable, it costs more money, it's harder to get, etc., etc., which I could potentially agree, unless I tell you that if you are in a desert, what is more valuable? Do you still want to have like a really big, beautiful diamond, or would you prefer maybe to have a bottle of water? And I'm positive that most people, if not everyone, hopefully everyone, will change to say that the bottle of water is actually more valuable. And this happens because the cost of something is not necessarily a reflection of its value. Actually, the consumption of a good, again, a good, I'm going to be talking about any kind of stimulus that a person can interact with as a good. So the consumption of this good, as we change its price, will actually indicate its true value. So it is not how much it costs, but how much we are willing to keep paying that cost to obtain that that good or that item in general. And to these changes is what we call the flexibility of demand. So the flexibility of demand refers to the change in the consumption of a good as its price increases. So, for example, let's say that someone is very in love and they want to buy maybe an engagement ring with some one diamond or more than one diamond, and they find some very cheap diamonds, and they decide to maybe put three diamonds in the ring. But then, if the price increases a little bit, maybe they will only put one diamond, or if the economy is the way it is right now, maybe they will decide they don't need any diamond on that ring. So you can see here that this curve which represents the consumption, is going to be decreasing very steeply. So it's going to be changing a lot. I'm going to go from buying 3 of these diamonds to buying 0 of these diamonds when the price increases a little bit. And of course, if the price keeps increasing, we are not going to buy any more diamonds. However, when we try to assess the consumption of water in the same way, we might want to think that maybe if we are exploring a new city or walking around in our own city and there's we're in the middle of this heat wave, okay, so and we find some very cheap bottle of water of like less than €1 or €1, we are going to buy 3 bottles of water because we are very thirsty and we are going to get as much water as we need to stop being thirsty. But maybe if we go to a concert or somewhere where the price is a little bit higher, we are still going to buy the water because we are thirsty and we really need to drink water. Otherwise, we are going to have to be dehydrated or feel bad or whatever. So we're going to keep buying this bottle of waters even if the price increases a lot. So you can see that here first with the diamonds, the decrease in consumption is very steep, but here the decrease in consumption is actually very flat. So we don't see a lot of decrease. And precisely this difference is what makes us realize that diamonds are not valuable in this sense, and water is actually a lot more valuable. So whenever we see this dramatic change, specifically a decrease in consumption when the price increases, we will be talking about an elastic good. It is elastic because it moves a lot. So if consumption changes a lot, it's going to be an elastic good. But if the consumption does not change or changes just a little bit, as the price increases, we will be talking about inelastic goods. So it is inelastic because it doesn't change. Something that is not elastic won't move a lot. So this would be the difference between them. So how do we measure this operant demand? What is the common procedure? The first thing is that we have to manipulate the price, which means that the cost of each good is changed. Generally, we're going to be increasing this change. And how are we going to understand cost? Cost, of course, from the economic point of view, cost refers to money, but whenever we are talking to within behavioral economics, we can understand cost as the number of responses required to acquire this good, the monetary price if we are doing a hypothetical test, the effort required to acquire this good, or any other criterion that we need to meet to obtain it. And this could be our independent variable. So this is what we are going to manipulate in order to see its effect on consumption, which is our second part of the operant demand framework, which is that we are going to be measuring consumption. Generally, whenever we are doing something in behavior analysis, we usually count or measure responses, but here we are not very interested in how many responses we get, but how many responses we are willing to get, or someone or something or an organism is willing to get or to do. So we're going to be actually measuring consumption in that sense. So how much of the specific reinforcer or good is consumed or purchased at each price or cost. This would be our dependent variable. And later, if we are a little bit more experienced, we would be analyzing the demand function. So if we include the price and the consumption in a graph, we can draw a curve, and then the form of the curve will give us information about the value of the reinforcer. You remember in my previous slide that the curve for diamonds was very steep and the curve for water was actually the opposite, was very flat. And this can give us information about the value of these goods. Often we will use mathematical models to compare the results, and this is what we would call the data analysis technique. I'm not going to get into the mathematical models in this presentation because that would take too long, but if anyone is interested, I'm happy to recommend a couple papers at the end of the presentation or by email or whatever you need. Okay, so there are two different types of tasks. The first, we have the operant tasks, which are relatively easy to implement with animals. And then we have the hypothetical purchase tasks, which are extremely easy to apply with humans, but kind of impossible to apply with animals. So for operant task, we are going to have the subject or the participant complete the task requirement to obtain the reinforcer. This is of course more common with animal subjects because it's easier to have them work to obtain something. And this can be made either intra-session, so we're going to be increasing the price of something in the same session, or between sessions in which we're going to have different sessions with different prices, and we are going to measure consumption in those like across sessions or across days. With the hypothetical purchase task, the participant will inform how much they would consume of a good given a specific price. So if a coffee costs 2 euros, how many coffees would you have? If a coffee costs 5 euros, how many coffees would you have? And so on. This is of course for human participants, and it is usually intra-session, and it can be of course implemented online, which makes it easier to get a lot of participants, although I am sometimes a little skeptical about the level of control. So we can see that both of these tasks have advantages and disadvantages, but it depends on the goal of our study, which one we are going to choose. So how would a normal operant demand look? Let's say that we want to assess how would coffee consumption change if its price increases. So let's say I really like whenever I'm at university or whatever to go to the cafeteria and have coffee with colleagues and just talk there for a little while. So let's say that the coffee in the cafeteria is relatively cheap. It is €1. I don't know if that's cheap for everyone in Europe, but in Spain that would be really, really cheap. So if the coffee is only €1, I might consume 30 coffees on 1 month. So maybe I will get 20 coffees in week days, and then I will get some more coffees during the weekend or something like that. But then let's say that the coffee price starts to increase and now they are €2 per cup. So maybe I will cut down a little bit and will have only 15 coffees in 1 month. If the price keeps increasing to now 4 euros. Maybe I will only get 10 coffees in that month because it's like, okay, I still want to go and chat with people, but I don't want to go bankrupt just because of the coffee drinking. And if the price of coffee increases a lot more to, let's say, 8 euros per cup, then maybe I will only get them on special occasions, which might be like 3 coffees in 1 month. So you can see how the consumption of the coffee, which is the same coffee that I like the same, will be decreasing as the price increases. So in general, we would see that we have on the y-axis the coffees or the goods that I am consuming, and on the x-axis I have the price. And we will usually see a graph that goes like this. In the first part of the graph, we are going to see that there is not a lot of change. We are going to call this part an inelastic part of the curve. And then towards the bigger prices, we are going to see that consumption changes a little faster. And we're going to call this the elastic part of the graph. Okay, so let's get a little example about how we can go from the animal lab to shaping public policies. There are a lot of studies that have been made on different topics related to like using the offer and demand framework in general. But I'm going to talk very quickly about this, which has directly impacted some public policies on tobacco use in general in the US. There are actually a few public policies, both on like regional, well, like city and state reach that have been made in the US. So I really hope that Europe will catch up eventually and maybe have us inform them on potential public policy changes. So in this study, Powell et al. Wanted to see how the reduction of the dose of nicotine would change the consumption of, well, in this case, the consumption for rats. So for this, they will expose rats to a procedure in which they can self-administer nicotine in the as much as they want. So they would have to use their nose and put it inside a small hole. And if they do this, they will get a dose of nicotine. So it's like they would be choosing to have a cigarette at any specific time. So after rats learn this, then these researchers will start playing with the different doses. So they are going to be decreasing the dose of nicotine per each response. Okay, so the rat will make the same response but get a smaller dose of nicotine, and also the length of the infusion will be shorter. So we can see here in the third column that the unit price will go a lot higher, which means that to get the same amount of nicotine, they have to work a lot more. In this case, to get with the last value, they will have to work 107 times more to get the same amount of nicotine than with the first value. So, well, this study actually has a lot of has other manipulations that are very interesting. But in general, what we would see is that in the first part of the graph, we are going to see that there are no many changes in consumption, even as the price is increasing. But as soon as the dose starts to get a lot smaller, we can see that the consumption changes a lot. So we can see here that this is relatively stable, this is relatively flat, but here we can see a very steep decline in consumption, which means that if we increase the price of sufficiently small doses of nicotine, we should be able to have people less willing, or well, in this case rats, but hopefully people, they should be less willing to keep paying to consume these cigarettes or these nicotines. So this type of research has directly informed or been used to change public policies on the regulation of nicotine doses of cigarettes. There are many studies, many reviews which have used this kind of research. This has been done with other type of drugs. This has also been done with humans, for example, related to COVID vaccination. There was a lot done during the COVID pandemic that actually impacted on how, for example, the efficacy of vaccines were presented for people to be more willing to get vaccinated and this kind of stuff. So whenever we are thinking of doing an experiment in an experimental setting, obviously we need to be thinking on whether this could have any real consequences or a real application like outside of the lab. And there's going to be some people that can actually use our results to do things that could potentially be like this case, like reducing the dose of nicotine per cigarette so that people will consume less nicotine and actually maybe be less willing to keep buying cigarettes if they don't have a big enough dose. So this could be an example with Opera on Demand. And now we're going to go to the delay discounting paradigm, or the discounting paradigm, as I usually refer to. This is actually a very on-fashion procedure in behavior analysis, specifically in experimental behavior analysis. If you go to a conference of experimental analysis, you're going to see that at least half of the presentations or even more are on this topic because it is very easy to apply on very different settings and can give us a lot of information that can be used in many different ways. So in order to understand this a little bit, in case you're not familiar with it, I could ask you, what do you prefer? So would you prefer 50 euros or would you prefer 800 and something euros? I think most people here would prefer the 800 and something euros because, I mean, why choose 50 if you can have 800? But maybe if I start manipulating this a little bit and ask you if you want 50 euros right now or 800 euros tomorrow, I'm thinking most of you, if not all, would still choose the 800 euros for tomorrow. But if I increase the delay to get these 800 euros to, for example, 1 week, maybe someone here would be like, 1 week, it's a little long. Maybe I need to buy something right now and I could use the 50 euros or whatever, and maybe you could change to 50, but probably most people will choose the 100 euros in a week. If I change it to 500 euros in a month, or even in a year, or even in 10 years, probably most of you will actually change to 50 euros now. I usually do this question in class, like in person, and people would be like, they would usually change to the small amount. And it's very nice to see how this actually works in an organic environment. But why do we change? Like, why choose 50 euros if you can choose 100 euros? And the thing is that the delay decreases or discounts the value of a reinforcer. If I have to wait more to get a reinforcer, then its value is probably lower, because a lot of things can happen between now and 10 years. Maybe in 10 years, euros will be very devaluated and there's not a lot of difference, or 800 euros don't present an advantage anymore. Or maybe in 10 years, you are rich, so you don't need the 100 euros. Why would you need them? Anything can happen. So that's why usually this any type of reinforcer will lose value if it is delayed. So how do we measure delay discounting? We will usually be using this delay discounting procedure, which will compare two alternatives. One with a small reward that's going to be delivered soon, which is called the SS alternative, and another one with a large reward, which is delivered later. So it's called the LL alternative. We have two types of procedures. The first one is the adjusting delay, which was the first to be described by Masur in 1987. And in this one, the organism that's choosing will have one alternative that is always going to be giving, for example, a small reward of 50 euros. And then they will have another alternative that will be giving the 800 euros, but as the person keeps choosing one or the other, the delay towards the LL or large later reward will be changing until we find a point in which the rewards of both alternatives actually have the same subjective value. So we are going to see which delay would be equivalent to a zero delay with only 50 euros if I'm going to be receiving the 800 euros. So this is one way of doing it. And the other way is what's called the simple delay discounting procedure, in which the organism will be faced with a choice in which both alternatives are the same, but they are presented in different stages. So here they will have a small delay to the 50 euros and a less small delay to the 800 euros. Then a different, I will ask the question again with the same delay for the small reward and a little longer delay for the big reward. And then I will do it again. In this case, the delays are going to be presented in the same order, regardless of the choice patterns of the organism or of the subject or the participant. Okay. And also in this case, the percentage of LL choices will be calculated for each delay. So we're going to calculate how many times the person or the organism chooses the LL option in every delay. For this, we will be, this is how we would present delay discounting data. We will usually see a y-axis in which the proportion of choice to the LL option is presented, and an x-axis in which the delay is going to be presented. The blue dots represent the percentage of choice of LL, and we would say that the indifference point falls at exactly 0.5 proportion of LL. So for this person, both of the options will have the same value if they combine the amount of reward and the delay of the reward. And in general, we would say that anything above the 0.5 value or the indifference point would be termed as self-controlled choice, and anything below 0.5 is going to be termed impulsive choice. Of course, this is if it gets closest to 0.5, then it's a little less self-control, a little less impulsive, but it's just a general way in which we can interpret this kind of data, which, as I said, you can see this type of data with any type of rewards that you can think of. You are probably going to be able to see it. In this case, for this procedure, there are also mathematical models that can be used to have a more specific or easier way to make comparisons between different subjects, different rewards, different values of delays, etc. But I'm not going to get into that because we wouldn't have enough time for this. So I've been talking about delay discounting because it's the type of delay that has been more widely studied, but there are actually other type of discountings, which are probabilistic discounting, effort discounting, and social discounting. So for probabilistic discounting, the alternatives vary in probability. Usually one is certain, so it has a probability of 1, and the other has varying probabilities. So you can get either 50 euros right now for sure, or you can have 800 euros with a probability of 0.8, 0.7, 0.6, 0.3, 0.1, etc. And people are going to be choosing between different probabilities, which can be sometimes problematic because not people don't always actually understand probabilities, but people try to do it. Then we have effort discounting, which of course alternative will vary in the effort needed to obtain each of the rewards. So for example, you will get, if you're a rat, you will get 1 pellet if you press the left lever once, but you will get 3 pellets if you press the right pellet 20 times, for example. And this is also going to be varying along the session, and we can see how effort will be interacting. There's this is a relatively new topic. It hasn't been explored that much, and the thing is that it is very hard to separate effort and delay, because usually something that takes more effort will actually take more time, especially when we are studying that with number of responses as the way to manipulate effort. So there's still a lot to work on this if you are interested. And then we have social discounting, which is, I think, is very interesting way to see this paradigm, or to use this type of paradigm. In this case, the person who's participating in the study has to make a list of people from closest, for example, their partner or their parents or someone that is the most close to that person, or that they love or like the most, to the most distant, in a scale from 1 to 100. So maybe the most distant would be someone you met once, but you don't really have any attachment to this person. And in this case, people will be asked whether they want to, for example, give money, or sacrifice their own money or their own reward to give to someone in X number of the list. So, for example, you can either get €5 right now, or your the number 15 person in your list will get €100, for example. I know, I find it very interesting, and it's very useful to try to study any type of socially significant phenomenon. So I think it also hasn't been that much studied. So I think it's something that should be studied a lot more. And this is, of course, something that we can only study with people, as far as I know. So yeah, there's a lot of room there to still work on it. So how do we go from the human lab to shaping public policies? Again, there's a lot of different procedures that have been made and are directly related to public policies in general. As I said, there are some studies with related to the pandemic, the COVID pandemic. There are some related to safe sex behavior, or risky sex behavior, etc. But I wanted to share this one, which I find it very interesting because it actually brought 3 types of discounting. So they assessed the delay, social, and probability discounting on environmental laws. So in this case, people had to answer a task on the computer, a hypothetical task, in which they would be asked questions about, let's say they had a farm, and this farm is likely to stop being sustainable because of pollution, or it's going to be to stop being sustainable because of pollution in X amount of times, or someone's farm. So your number 3, number 5, number 99 of your list is farm will stop being sustainable due to pollution, for example. So what they were measuring 2 things. They were measuring the concern that people had and the action that people were willing to make, depending on either the delay, like how delayed the consequence would be, how distant or close the person that was going to be affected will be, and the odds against this happening. And what they found is that people were more concerned than actually willing to do something about it, especially when it comes to social distance. So people, they would be concerned, but they discount the willingness to do something faster if the people who would be affected is not very close to them. And very interesting, there were no differences when it comes to evaluating the odds, the probabilities, which goes in line with what I said now. Like people don't usually really understand probabilities, so we need to be very careful of how we interpret this kind of data. This type of research could be used to inform public policies on how to increase public engagement in sustainability actions. So, for example, maybe we can direct the, the publicity or the calls or whatever to make people more sensitive to whatever message we will be trying to transmit. And if we talk about odds, people are probably not going to change their behavior, but we start talking about how this is going to affect your loved one's life in the future or whatever. These actions are probably going to work better. So this is still something that needs to be thoroughly explored. I think it's one of the topics that, even though it has been analyzed a lot from behavior analysis, it hasn't been analyzed a lot from behavioral economics. So I think there's a lot of work to do. If someone's interested, there's a lot of room to work on this. So some very quick final recommendations, just to give some time if anyone has any questions. The first one is I deeply recommend the Handbook of Operant Behavioral Economics, which was published last year, I think, at the beginning or middle part of last year. If you're interested on this topic, this is very good. If you have any trouble finding it, send me an email and I'll be happy to help you out with that, because I think it is very valuable, because it has come to the point where there's so much things that we need to do in order to work in behavioral economics, that we need, like, this is a really good basis if someone wants to get into it. Go to conferences, if that's the best advice I've ever received as a student, and it's an advice I like to always pass on and to share. We will have the ABI conference in Prague, here in Europe, with collaboration from EABA. So I think that's going to be a very good opportunity to attend a very interesting event. Of course, follow social media, EABA on social media, so you can get all the announcements and everything that's going to happen. Also for the conference in 2027 that I'm looking forward to attending. And yeah, just stay close to your local recommendations as well. And this little rat is telling us to collaborate. There's, as I said, there's always the question of how we experimental analysts can translate these results into something more directly valuable or that can be applied. And I always reply that I need you, the applied behavior people, to tell us, the experimental experimental people, what you need, and we can maybe start to, I don't know, try to solve these kind of problems. And if you have any questions, I don't know if there are any questions right now, I'm happy to answer them. And if not, if someone wants to send me an email, I'm also happy to answer by email. I might take a little long because it's summer, but I am still a bit busy. But yeah, that's it. And thank you everyone for their attention. And here I am. In case there are any questions, we have 10 more minutes.
Okay, thank you, Gabi. Thanks for this really nice overview of the field. To be honest, I really enjoy that presentation, and I have different questions. But first, I would like to give others the time to ask different questions. I'm not entirely sure how people can engage. Maybe by writing questions on the chat, and maybe I can read it. So if you have any kind of question, now is the time, okay? I'm super, probably you already know, but I'm super interested in experimental behavior analysis on human behavior. And I think that topic really combines both fields, like animal lab or some procedures that they were developed in the animal lab with other procedures that also they are studied at human labs. Okay, so I have a lot of questions, a lot of probably no more comments or more than questions, comments. But my first question for you: how do you think that both fields, like verbal behavior research and this behavioral economics world, have something in common?
Yeah, probably they do. I think there would be relatively, but I don't know if easy to make, but I think it would be a good idea to have maybe different types of instructions, verbalizations, etc., that will that can be tested on how they would allow someone to behave more self-control, for example, to choose the self-control option more. So if I present the information with in this way or in this way, how much the person is willing to wait to do whatever the instruction is saying, or how much they are willing to work for whatever the instruction is saying. So I think it can be easily adapted. And in general, whenever people are working with humans, I think the verbal behavior cannot be taken out of the equation. So it actually has to be considered, and if you can manipulate it to test it, even better. Which is, I know that is what you do. So
Yeah. Well, I have the privilege to ask, so I will. I'm asking my own obsessions and my own problems. My problem sometimes in doing this type of research, I'm not quite doing delay discounting research, but I'm trying to do some kind of research with delay contingencies. No, I want not to use like a hypothetical task, but more real consequences at the lab. So I think that both worlds, they're super connected, and I would love to collaborate in that sense. I mean, yeah. Another question is about the scope of the experiments and then the application, because sometimes, but I don't know your opinion, because sometimes at the lab we have individuals in a control setting, and behavior analysis work with individual behavior. Maybe we can group that behavior, we can group the results in different groups, but still we work at individual level. How do you think that translate to the real world, or to the more bigger groups in the society?
I think that's actually one of the benefits of working with it within behavioral economics, because economists has been doing that for a longer time than behavior analysis have existed. So I think they have a more efficient way of extracting the most important part of individual behavior in order to find these coincidences that we can make work with a larger group. I think another very important part, which I didn't get into because of time, is mathematical models, because when we are working with mathematical models, we are able to do like a summary of individual behavior that which is made from the group data but can be applied to individuals and can help us make better decisions in that sense. And I think that's why there are so many steps, and that's why sometimes people have a hard time seeing how to go from the lab to the real world. So in general, if we go from the animal lab, you are not going to go directly to the public policy. There's always going to be some steps in between. Generally, you go from animal lab to human lab to more on-field observations or modifications or small implementations of whatever you are trying to test, and then the public policies are going to be developed in that sense. So it is always important to take into consideration these steps, and to also consider that, in my opinion, we cannot do everything. So there's some people working in experimental stuff. There also should be some people working in translational stuff, and of course the people that are working in the applied settings.
Okay, okay. Thanks for the answer. And my last question, maybe this is something that is already covered, or maybe this is something that is not even interesting or whatever. Okay, but when you were explaining the operant, the operant demand type of work, you presented like animals and then humans, and I was thinking how well that it translates when we use, like for example, we use a token, like a condition reinforcer, like for example money, and the rats, they're not using that condition reinforcer as an exchange. They're just using their own behavior. Do you think that it's a problem? Do you think that that's an opportunity to do some research on how we exchange things? Just give me your comments on that.
I do think it is a problem, and I do think that most of the or I don't know if most, but like the bigger part of the problem in translating stuff is that there is less research with real consequences with humans every day. So most people are going into hypothetical tests and hopefully into token stuff, but not even tokens, but even like hypothetical, and they will just get like a small reward or something just as a thank you and not as a part of the task. And I do think it's a problem specifically because of the value that this kind of consequences have. So the value of food for a rat or a pigeon will be bigger, and they will be a less elastic good for them compared to a token or a point in a computer task for humans. So I don't think it is something that should be further studied. I don't think it has been. I know that in delay discounting, there's there has been a lot of discussion about this because money discounts a lot slower than any other type of reward. And Peter Killing has a very interesting explanation for that, which is that, well, he has he develops this in a mathematical model, but the thing is that money can have a bigger utility in the sense that if you get money, you can get different things. But if you get food, you can only get food, and it will come to a point where you're full and you don't need any more food. But with money, you can always, if you get full, then you can get something to drink, then you can get something else you want, or this kind of stuff. So I do think it is a problem. I don't know how we can solve it, because I know that doing research with humans with real consequences can be potentially either very expensive or ethically problematic. so
Yeah.
so yeah, I'm not exactly sure how we can test it. And but what I do think is that we could start testing token like things with rats. Actually, my first study that I did within behavioral economics, rats were, well, I tested the value of not of the specific consequence, but of an alternative that had some probabilities. So I might be one like approximation to that, but there are not a lot of studies that go that way, as far as I know.
Okay, super interesting. Thanks for your insights and your answers to my question. So I think that we don't have any more questions so far.
There are two questions in the
really?
question.
Oh my
Yeah,
God.
I don't know if you see them.
I cannot see them.
Okay, one is whether they will receive the CU certificate the same day, which I don't know. I cannot answer that.
Okay, maybe our friends from Behavior Live will answer that question.
Yeah, and the other one is what can we do when policymakers are not responding to our data? That's a very interesting and hard question to make because I don't really have an answer to that. I think we need to insist to keep trying to show data, to have better aligned data to what the policymakers actually want, not in their interest, but what they are focused on. I think that at least here in Spain, there's, for example, one call for projects which is it's open just now, and it is actually focused on ways in which they can improve policies. So I think maybe the government is starting to see that they need data to improve. So maybe it's just a matter of being patient, and hopefully they will respond at some point. But yeah, I think that's it.
Okay,
And those were the questions.
I'm not seeing those questions. So is there any other question?
No, there were only those two.
Okay, thank you, Gabi. Thank you for the presentation. Okay.
Thank you for the questions. It was really nice seeing you. Yeah.
Bye bye.
Thank you. Bye.